I want both switches to turn that light on and off, for example, or I want one switch here that turns that light on and one switch there that turns that light on. That is part of the architectural requirements, but the solving of that problem, that's what the electrical engineer does.
Yeah, but I think
let me finish. So there was architectural drawings which did not include electrical. They included electrical requirements, like a plug here, a switch here, and a light there. Then those drawings go to an electrical engineer, a plumbing engineer, structural engineer, who then do the structural engineering, electrical engineering, plumbing engineering. So I saw that, one of the things I say is architecture is much more about the why. It's exactly what you said. Why are we doing this and what do we want? And engineering is how do we do that? We need to
you're telling me the answer,
the same.
But what I'm suggesting is that you're thinking in twos. I'm thinking in threes. So you've got the first bit, which is what you talked about. I want to press the switch and that comes on. The second bit is what are the capabilities required to make that happen? And the capability is an electrical network that connects all the electrical bits. And there's another capability, because that switch I also want to connect to a pump that's
connected. Who designs the electrical?
Hold on a second.
Capability. Who does that?
Hold on a second. So then the pump is then connected to the water, which is another network. And then the water is connected to the sewage, which is a third network. So I've now got three networks which I need to put in place, each of which requires a completely different engineering skill set, but which need to interoperate to generate something which is bigger than the parts that they've.
Okay. So what did the architect do?
So that's the middle bit, and then the third bit is the engineering. So I think it goes architecture. And the architecture has these two pieces. One is, if you like, the use cases, how the building is going to work to the end user. The second part is what are the capabilities, the logical capabilities that need to be built in order to deliver that use case experience. And then the third bit is that bit.
So we're agreeing on this, basically.
I'm saying there's three. There's a conceptual, logical, and engineering.
Okay. We're not talking about.
And the architecture brings those first two together.
Okay, but we don't have three roles. We don't have architects, engineers, and some other random role in the middle that no one knows the name of, do we?
Yeah.
We're trying to get to the core of what's the difference between architecture and engineering. There are various
we get lots of confusion in businesses because we only think in these two. We don't think in three.
In fact,
that's the source of the confusion that we're trying to address.
Okay, you're saying I'm thinking in two, but you're correct because you're thinking in three. Actually, my framework's thinking six. There's not 3 levels. There's actually 6 levels.
Well,
so it's not how many levels, because architecture and engineering is performed at different times. You don't do application architecture when you do enterprise architecture. That's later on, right? But just because it's later on, we don't call it engineering. We still call it application architecture.
And I think one of the key things is that ultimately, when you take the current state to a target state, and architects can look at the whole, and also within whatever frameworks or methods that are applied, generally looks at the level of maturity and what the starting position is, because you can't go from typically say A to Z. You've got to do the alphabet in the middle to be able to get there, and there's certain things you need to develop a roadmap for.
We need to move on.
I think what happens is that the architect has to integrate the logical capabilities so that they deliver the outcomes that the end user, who's me in this case, wants. And then the engineers can come in as specialists in each of those logical capability areas and build it such that that particular domain works. So engineers are nearly always domain specific. Yeah. Architects integrate the engineering domain.
So does architecture
in order to deliver the outcome that the user wants. And so I think you've got this.
Can we say architects are generalists and engineers are specialists?
Because it's like it seems to me that architects are setting the context or the sort of by which engineers can perform in, because this is kind of the what and why I want it, and how do I go about it? How do we make it so? I think that's what you turn to engineering capabilities.
It's your point about decomposition. You're decomposing,
yes,
but it decomposes fractal-like. So every decomposition, because it's a system, you're decomposing one system
Yeah.
into a set of system components that themselves are systems, which decompose into sets of systems which themselves are systems. So everybody, you need a specialist in every systems area, but every systems area will have within it systems.
You've got systems, you've got subsystems, and
Until
you've
you-
also got you've also got interrelationships between systems, because
Yeah.
those systems, as you said, have got to interact with each other. So you define the systems, they themselves are systems, but they've got to interoperate, because it's all to achieve one thing, isn't it, overall? Which is
I
focus
slightly
orientation.
disagree with that in the sense that with architects, you can have some architects that are domain specialists that are a bit of a blockhead and will go down right into the details still, but because of the experience, they're generalists and they're able to step back and look at the
But isn't that because they're wearing two hats? They can put
I think it
an
depends
engineer's
on
hat on. It's not the
skills,
architect's job.
experience, competence, attitudes and behaviours. It's a combination of all of those things. But one of the things generally from defining the what and the why, what you'll generally find is architects live in more of a change world of transformation, and maybe defining what guiding principles are for how the state should exist when it's arrived at, or how it goes through, because an engineer could live in a change and a run world where the past might not necessarily cross as much with an architect in the run world, because the how for the engineer is it's broke, fix it.
What could we put over here? If architects are kind of looking at guiding principles, what might we put in the same category of
Enabling principles.
standards?
Standards,
Operating
enablement,
procedures,
yeah.
operating
So,
procedures or something.
Let me go through some differences that we've defined, because if everyone can get a very clear idea of the difference between architecture and engineering, I think companies will work a lot better together, people in them. Because the word architect tends to be used as a moniker for people who need to be paid more money or who need a job promotion. First you're a solution engineer, and then the next day you're an enterprise architect. How did that happen? So what we're looking at here are different categories. Different categories, and we are not saying that. Let me zoom in a bit. We are not saying that architecture. There's no hard line between these things. Yeah, we're saying architecture is more about that, and engineering is more about that. It doesn't mean exclusive. It means there's a grey area, which is why we fade from blue to green here. So let me just run through these. This is what I think. Afterwards you can discuss. So I think architecture is more about art than science. It doesn't mean it's not science, it means it's more about art than science, whereas engineering is more about science than art. Because engineering is based on the science of load bearing and all of the rest of that stuff. Architecture tends to be more about looking at the why, engineering more about the how. You said why and what, I agree with that. Architecture tends to be thinking more about outside in, that is thinking about the context of a system and what the context is driving the system to do, whereas an engineer tends to be more about, I've got to design this system and it has to work with that stuff out there. Architecture tends to focus on the whole, whereas engineering tends to focus on the parts, which I think is one thing we've covered. In translation, we're going from the why to the what, or the what to the why, depends on how you use the words, whereas engineering is going more from the what to the how. So you can see maybe the what is in the middle, so we go from why to what to how. Maybe this is in the area of that third middle thing that you're thinking about. Architecture tends to deal in uncertainty. Engineering deals in certainty. Engineering does not say, will this floor support wall? No, it definitely will support wall, we are certain. For architecture, an architect's impossible as an opportunity. Anything that's impossible is, all right, let me explore that. For an engineering, that's a constraint. It's impossible, that's a constraint. In terms of function, I'll talk about these two terms, abstraction and elaboration. So there are at least 3, if not 4, ways of abstracting and elaborating. So the simplest is by omission. So if we have some information going from high level to low level, by omitting information, we are abstracting. By adding information, we are elaborating. The second simplest one is the composition decomposition. If we are elaborating, we are decomposing things into smaller and smaller blocks. If we are abstracting the composition, we are composing. It's composition versus decomposition. In object-oriented types of language, abstraction is supertypes, elaboration is subtypes. It's a type of. The last one, which is very, very connected to architecture, is this whole, it's called elaboration and realization, not idealization and realization. So idealization goes up, the further we go up, the more ideal the information is. The further we go down, the more real the information gets. This is where you get contextual, conceptual, logical, physical, operational. That's where those things come from. So all of these four ways are all ways of doing abstraction and elaboration. But architecture tends to always be going up. We compose things into bigger things. We think of bigger types. We think of conceptual and logical and conceptual would kind of go over the thing. Whereas engineering tends to be about decomposition, adding more detail, creating more types from supertype, for example. Architecture tends to be finished when there's nothing more to remove, as I said before, nothing more to add. The most important tool for an architect is his eraser. I would also say his mind. This actually comes from there's an architect called Francis Lloyd Wright, I think. In my book, there's a whole load of quotes from him, which are fantastic. You read his quotes, he's talking about building architecture. But you read the quotes, they apply to any type of architecture. You can apply his quotes to solution architecture. So we're about erasing things and thinking about things. These are about drawing things, more and more things, and building things with your hands. In terms of work, architect tends to be more about thinking, engineering is more about doing. Architects consider what is yet to come. We have to plan. Well, what's happening? Like someone said earlier on about planning for change, later change. So we think about what is yet to come, whereas engineering thinks what has been. Or we're going to build it this way because that bridge was built that way, and that's a really great engineering way of building the bridge. The best friend of an architect is an engineer. The best friend of an engineer is an architect. A lot of the time when you talk about any of these things, you get into arguments because people think it's hierarchical. Architects are more important than engineers. They're not. They just do different jobs at different times. That's all. Architect tends to be driven by the client. So the client says, the architect says, what do you want from the client? And the engineer says, what do you want from the architect? They tend to view breadth and big picture, one of the things that we wrote down, whereas engineering is more about depth and big detail. Architecture wins long-term. Architecture is all about long-term wins. It drives me mad when people employ architects and they go, right, we need to concentrate on some quick wins. So don't talk to me, don't talk to the engineers. Architecture is about long-term wins. It's setting the fundamentals in place. Whereas engineering is much more about short-term. Maybe you can think of those Scrabble letters I was having. This is more about long-term thinking of the big picture that's going to change over time. This is more about short-term, let's do engineering, engineering, engineering. But engineering without the context of architecture is prone to lots of problems. Can you cost justify architecture? No. Maybe you can, but basically you can't. One of the good things Zachman says is you can't cost justify architecture. I don't think you can, because it's all about the long term. It's all about, one of the things in books and things, is that architecture a bit like snake oil salesman to a manager. One of my slides says, to a manager, how can a manager discern between a snake oil salesman, a charlatan, and an architect? It's very difficult, because they both kind of talk in the same way. Oh no, this is fantastic, do this, really important, if you don't do this you're going to die. And when I see the benefit, next year. The true value of architecture is intangible, which is why you can't cost justify it. Quality, how do you measure quality? How do you measure scalability? How do you measure the fact that we put in place an architecture that's going to allow us to do whatever we want to do going forward? Whereas engineering is much more tangible. It's literally bolts and nuts and pieces of software and whatever. Architects, when they are wrong, they love it. I love it when someone tells me I'm wrong, because it means I can change things and improve things, and the next time I talk about something, it's improved. I absolutely love it. Engineers hate it, because when engineers get things wrong, people die, potentially. Serious things happen when engineers get things wrong. So they really don't like to be wrong, which is fine. Change, they're all about, architects tend to be more about creativity, which is creating new things, thinking off the wall and all the rest of it. Engineers tend to be more innovation, so I distinguish the two in, that's more what's the words? I'll come back to it. I'll remember the words. Architecture is more about the lines, engineering is more about the boxes. So if you draw a picture with boxes and lines, the architecture's the lines, not boxes. The engineering is boxes. It's not a hard line.
Are there the relations between the boxes?
Yes,
and
the
lines?
relationships.
Talking about the objects and the relationships.
Yeah, it's the networks. So,
Yeah. One of my sayings is the values in the lines, not boxes. Think about like an architects. So,
Yeah.
On the uncertainty, do you think there's something about risk in there as well? Is it uncertainty and risk?
Well, is it risk? Well, risk is assessed uncertainty. Risk you know about.
Yeah.
Uncertainty you just don't know about. It's the unknown unknown, isn't it?
The uncertainty
So the
implies
relationship between risk, uncertainty, and certainty, isn't it? Because you're trying to make uncertainty certain through an assessment of risk.
you can't make uncertainty certain. It implies that you worry about things you don't know.
Yeah.
So the architect has to design something so that it will survive unknown events. Whereas
so if the category is
an
risk,
engineer
So in fact, it's
engineer
flexibility.
tends not to do that. They tend to design for risk.
Yeah.
so if the category is risk, would we say that engineers can be more clear about risk than engineers?
Quantified.
Is it tolerances or things like that?
There's a
Isn't
high
it?
probability that they're going to reduce the risk a lot more than an architect.
Yeah, because I guess they think in terms of tolerances. I don't know if that's relevant or not.
They're working on the.
It's like they can put a
It's
signal on it.
They're working on. They're working
Put a
on the,
statistic on it, can't
they're
they?
working on the unknowns, whereas the architect is working on the unknown unknowns.
Yeah.
Mm.
Yeah, sort of know what's it.
It's the known unknowns.
There's the known knowns, there's the unknowns that you know about, and there's unknown unknowns. You don't even know you don't know it.
And that's what the architect. Yeah, and that's what the
That's
architect.
what architects got to deal with.
You see, that Donald Rumsfeld, when he said that was so important,
It
what
was.
he said.
It was.
And what did the stupid people on the news go? Oh, he said the silly thing, the knowns and knowns and knowns. It's like, no, that's really,
Yeah.
really important.
It is.
Yeah.
It is. I agree. I quote it myself exactly because of the validity in that statement.
Yeah.
Very powerful statement.
It was. Yeah, I was.
I think that's quite interesting because then it starts bringing in like a third dimension where we see sort of outside in, inside out, and outside out. Because when you're now starting to think about the experience that you're trying to provide to a person, the user, that you need to think about, okay, where does that actually begin? And so it might be thinking beyond the normal constraints of an enterprise, wherever that might be.
Well, enterprise is creative.
Yeah.
It's a human endeavour. We make enterprises, we create things, we create poetry or whatever it is. Enterprise is like, it's in the same bucket, really. It's a different form of creativity. It's creativity. And that's what the architect's got to deal with because you're trying to architect that creativity. So you understand it and then make it so, and I guess that's where the engineering comes in.
I know when I look at risk, I think about business continuity. So it's not just about there's a fire, there's a flood, there's a war, there's an asteroid, there's a 747 laying on the building. It's also the other things about, what happens if I lose this service because of a business reason or security reason or whatever. Those are the kind of risks that I'm thinking about what we're trying to actually cover. And if there's a business that doesn't cover that, we're all need to accept it.
It's the other thing. I can always quote the classic examples like that BlackBerry and Apple. You're doing nothing wrong, it ain't broke, it doesn't need fixing. So actually the context, you're just not aware that somebody's coming in with a design, what the purpose of handheld devices, mobiles and so on.
Yes.
Look at a completely different lens. That's your risk, you're finished, basically.
Yes.
And yet, there's nothing to suggest there's anything wrong. So, how can architecture capture
Yeah.
with simple
Difficult to quantify risk, and even when you
Don't know it's even there.
even when you identify it, to get other people to believe it's a risk
Yeah.
is difficult because you can't quantify it. It all sounds airy fairy and charlatan-like.
It does.
I can't help feeling that there's something that an engineer does which involves taking things, components that already exist and are proven, and putting them together in well-known ways. So if you're building a helicopter, for example, the job of the engineer is to take components that are well understood and integrate them in ways that the engineer knows will deliver the outcomes that the architect has specified. Whereas the architect is doing something similar, but at a much more conceptual kind of level.
Yeah. They're both doing reuse, aren't they? But the architect's more logical, conceptual. Because the architect of a building, the patterns they're using is arches and plinths and things like that in buildings. That's kind of the... reusing those patterns.
Come back to this point about networks. So if you're an architect, the thing you're designing, the building, is the corridors and doors and rooms, which is the space network
Yeah.
people are going to use to get to things. Then you've got to say there's another network which is the electrical network, which is going to connect to all the bits. And there's another one which is the drainage network, which is going to take all the waste away and all the rubbish away. And so, and if you think in the different layers or types of networks, all of which have to come together, so that when a person is sitting in the building at their desk, they're connected to the space around them, the lighting, the plumbing, the waste, the knowledge, the information, all of the networks they need in order to do the job. The architect's job is to do that thinking, which is very conceptual. And then the engineer comes along and says, you know, I'm the space architect, I'm the space engineer, I know how
We're
to
back to this, aren't we?
I think goes back to this point about networks. So I
think there's another dimension as well, because
being recognised in this.
I'm just wondering
Networks is in the lines, not the boxes. Networks is all about the lines, the relationship between the desk, the relationship between the desk and the toilet and the light switch and the water. It's all the relationship.
I think what goes beyond the line side.
But what I'm
because
saying, I think it's more fundamental than we're doing. This is the sort of, I think what I've so in the last couple of years, there's been a huge amount of literature and writing on networks and complexity coming out of Santa Fe Institute and things like that. You've got Geoffrey West's book on Scale, which is all about networks. You've got Barry Bass's book, which is all about networks. There's been a huge amount of development thinking about the power of networks. You've got Niall Ferguson just written that book, The Square and the Tower, about networks. I think as architects, we need to catch up, look at that thinking and say,
So
what does that mean for
So
us?
I agree with that thinking because with the lines and the boxes, so traditionally that used to be things like how do we put it all together, how do we integrate and create something, where I think now what we've seen definitely from influence within the industry in sort of the digital and cognitive era coming together is that now it's, as well as doing the lines, you also need to understand the outside of the boxes, so you've got interchangeable boxes. So as you're looking at the reuse of patterns and blueprints, that those boxes can move and they become interchangeable. So I think with the box side, the architect has to understand the box and the dimensions of the box, but what's actually inside the box, sort of the engineers still living inside the box, doing that level of decomposition.
What you can do is with boxes, you can go down the hierarchy, so you can do the subtypes and that, you can define that, and you choose how you can polymorph and substitute it, so like a Manchester employee, for example, and the dimensions of that are retained. And the way that you do the sort of the houses is the relations, because really the specialised boxes is a relation. It's a specific kind of relation. So you could draw it as a relation, manager-employee, yeah, it's just another relation. So I think that's the way you try and square the circle, is you could have has and is's, and you can,
Or your eyes and we's.
your eyes, or whatever it is, whatever
That level
whatever
of
relations you want to put on your graphs or on your boxes.
Are you saying then that the engineer is more interested in these ISA-type relationships?
Well, my experience has been that engineers think that ISAs is a very constrained way of thinking. When they think of composition and decomposition,
Yeah.
Architects think, well, how can you break it down according to subtypes? So you have a box, and then you say, right, this is a new employee self-service system we're trying to build here. What sort of employees have we got? Well, we have managers, we'll have executives, we'll have casual workers. And you think in that sort of thing, whereas an engineer will not think in terms of ISAs or hazards, so they'll think in perhaps in terms of what are the parts of the employee self-services. To them, that's a way of decomposing the employee self-service. Whereas an architect may think in terms of size. And sometimes I think they're both, to me, the ISA comes out of software engineering, so that's the word engineering in it. But there is, I'm noticing, when I've seen something like that, and they've said, oh, that's not an ISA, you can't do that. An engineer will say to me, well, I'm trying to I've got to understand this part, to recompose it. And that's a fundamental way of thinking that's different. And that's quite a challenge.
Engineers understand by decomposition.
Yes.
Architects understand by composition. By thinking at a higher level, bringing things.
Software was taught many years ago, really in terms of functional decomposition. And what you're talking about, I think, is more data decomposition, which a lot of places never taught, and I'm not sure whether they teach them today. So I think that also.
That's right, and it's actually multifaceted. I mean, we look at development, we're off topic here, we look at development programming languages, you can see
Well,
it's worked with
methods
different
like
paradigms.
LSTM.
Yes, it is.
Data modelling.
Yeah, exactly.
I remember saying as a ADM when you had the data models and all that kind of stuff. But I think that's the way of, this congruency in the way of thinking, I think that's.
I think the architect has to be able to do both decomposition and I think you have to go in both directions, because I think what happens is the business says, I want this, and they give you something visionary. I want to be the Uber of whatever.
Sure.
And then you're decomposing the why. So if you want that, then you must have these parts. So you've now got a part of decomposition. And then when you get down to the bottom of the part of, you're back to whether it's a use case level. You basically recompose back up the ISA. You say, well, that part is a type of and it's a type of electricity, let's say, which therefore is part of the electrical network. And this part here is a part of a drainage, and that's part of a drainage network. And then you've got your engineering domains. Then you can go in and get your engineers, and the engineers will do the made of network. The made of decomposition, which says, this bit, and in software, this bit's going to be SAP, that bit's going to be Microsoft, that bit's going to be, and they're doing a made of kind of structure. And so you've got three structures. You've got part of, type of, and made of. And I think the engineer, the how is made of, the architect's doing the part of, and the interface between them, which is what you've got on your list. Is that what?
But it's also interesting, this was
that type of.
We need to, I have to put it because we're running out of time.
Okay.
Unfortunately, but there's a slide on our website or part of the stuff which explains all this abstraction, elaboration, and things like that. But just to finish off this thing here, unfortunately we could be here. I prefer if this section was like 3 hours long, and that we started late because we didn't have this and that, etc. Anyway, so. There's something also in our frameworks called the Pragmatic Architect's Creed. There's 3 pillars of statements: communication, integrity, and understanding. And then there are things that that architects are and behaviours of architects. You can go to pf.com/creed, and there's lots of words written about all of these things. So I just really, not to go through this, but I just wanted to point that out. I'd like to see, when people get recruited, we pay companies pay more attention to who they're recruiting. Because when I've been recruited as an architect, I don't think in all of the interviews I've been to and of all of the jobs I've gone for, anyone's really asked me any questions to do with architecture to find out if I'm an architect. This is what I'm saying. People employ people as architects. They have no idea whether they're an architect. They're probably not. So that's a useful thing. The other thing, I'm going to do that survey. Anyone change their mind about what they thought they were and what they think they are now? No? This works better when there's 50 people in the room, obviously. To let you know, we have PF training is free. It's self-study training, but you can get trained and certified in our frameworks for free. Just go to pf.com/free. We have various books. There's another 4 or 5 books that's on that list. They're either available as physical books or Kindle books or free. If you just go to pf.com/books, there's a link at the top to go to ISSUU, ISSUU, so you can read everything for free on that. So you get free training, get trained and learn it all for free, read books online for free. Or pragmaticea.com or pf.com, goes to the same place.
Are you the guru behind all this?
Yeah. All this was created by me working at various companies over about an 8-year period 6-year period from 2002 to 2008, failing at enterprise architecture. And the reason I failed was not necessarily because I didn't know what I was doing, it was because the people I was working for didn't know what I was supposed to be doing. So they'd get me doing solution architecture jobs, so I have to explain that. Here it's not this big essay, it's different. So over that period I created a lot of stuff to stop people failing in the same way. That's why I say it's 20% of the fundamentals. Half of it is do these things, because if you don't do these things, you've got a 90% chance of failing. And the other one is, if you do these things that we're telling you not to do, you've probably got a 90% chance of failing. Something I want to try to start is this Global Association of Enterprise Architects and Engineers to try to build a profession. Various people have tried to build professions in the past, but really all they want to do is they want to own enterprise architecture. So this is not enterprise architecture focused, this is enterprise focused. And the 2 fundamental disciplines are architecture and engineering. We need a profession. We need to stop people building houses, or we need people to stop architects architecting houses when they're engineers and they haven't had any architecture training. They don't even know what architecture is, and yet they're architecting houses. We don't let that happen in the physical world. Well, enterprises are very, very, very important. People's lives depend on them. Their work depends on them. We have to start getting serious about this stuff. So if you just go there, you can send an email saying, I'm interested. Basically, I'm looking for people to run it. I'm looking for people to be a treasurer and be the managing director. And so I don't really want to own it, but I'm trying to create an environment. Because I've spent 30, 40 years working in a system whereby a lot of the time you feel depressed. Because you're working on a project that you know it's a crap project. Everyone on the project knows it's going to fail because it doesn't integrate with that. They weren't allowed to buy it. Everyone moans down the pub on a Friday night and all the rest of it. And it's just so depressing, especially when you're working on a project for 6 months that you know is rubbish, and they finally can it, and then it's like 6 months of my life, my passion, has just been wiped away, or wasted 6 months of my life. So this is not only to create a profession to help enterprises, but to create a profession, not a union, but more a profession for people working in the transformation domain to start taking ownership of their domain and saying, hang on a minute, you're forcing us to do the wrong thing in the wrong way at the wrong time with the wrong thing. And then when it goes wrong, you blame us. We're not going to take that anymore. We're professional people, we know what we're doing, and we need a profession. So don't have all that. And I'll just leave you these links. All the stuff that you've seen today, I'll put this up again in a minute, but all the stuff you've seen today is in the frameworks. If you go to, just go to pf.com, just go to pf.com. If you click frameworks, That will then load up a page of every single image in both Poet and PF. And when you click on one of those images, so for example, we've been looking today at architecture and engineering, so that slide. If I click on that slide, then you get the slide, but then you get the words from the book associated with that slide. So everything you've seen today, like this, including this thing that we just looked at last, go and look at it. That's another way of consuming the content for free as well. We've kind of finished.
Finished, brilliant. Well,
Any last questions from anybody?
thank you, Kevin. Lunch is being laid out, so help yourselves.
Thank you.
Thank you. Thank you.